Okay, example 1, page 432. We're looking at rational functions with transformations. Okay, so a rational function just means it has a top and a bottom in your equation. Okay, so, and the transformations go the same as how they have gone before. So you have vertical and horizontal translations, and they move the same as any of the other equations that we did before. Okay, so example 1, I can't get my slides to come up, so we're just going to have a blank screen. Example 1 says, analyze the function y equals 10 over x. Okay, it says use a table of values and graph it. Identify characteristics of the graph, including behavior of the function or non-permissible values. Okay, does anybody know what a non-permissible value of this equation would be right off the bat? 0. Perfect. Because you can't have x is equal to 0 because that would make the bottom undefined. So x can't equal 0. So that's a, what is it? Non-permissible value. Okay, and what we were supposed to do first was to graph the equation. So there might be, you could pick anything for x and we're going to see what it's going to be for y. But let's pick a few points that are going to make this an easy equation to graph. Okay, so if I had 1 for x, if x was 1, what would my y be? Did I hear 10? Yeah. Okay, so if x is 1, y is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then say if x was 2, y would be 5, because 10 divided by 2 is 5. Okay, so 2 and 1, 2, 3, 4, 5. And then what if we had, I'm just trying to pick even numbers is all I'm doing. You could do decimals and you'll get the shape of how this is going. What if I had x is 5? 10 divided by 5 is 2. So that would mean my y is 2. So 1, 2, 3, 4, 5 over on the x and 2 on the y. And then what if my x was 10? My y would be 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1. Okay, so you'll notice the shape goes like this. So it's creeping towards the 0, but it's not going to cross it because that's undefined. And it creeps towards this one and it's not crossing it either. Okay, and if we had used negative values, we would get the same shape just in the reverse side. Okay, so if we had, if we continued with the same table and say we had minus 1, if x was minus 1, 10 would be minus 10, right? If x was minus 2, y would be minus 5. So we'll get the same picture. It's just going to be on the reverse side. Okay, so if we're looking at the characteristics, it has a table on page 433, and we can look at the picture we've drawn to see the characteristics. So the non-permissible value, we said x can't equal 0. So that means that's your asymptote that your graph is going to never touch. It's going to get closer and closer and closer to it, but never touch at it. Behavior near or non-permissible value, it says as x approaches 0, y becomes very large. Okay, so y is getting bigger and bigger and bigger as x is getting closer to 0. We have end behavior, they say as x becomes very large, y approaches 0. So all they're saying is if x was 0, y is a big number. If we get closer to 0 here, then our y becomes a smaller number, like a decimal amount, because it's going to get close to 0 but not quite. The domain. Okay, so the domain in here is going to be x can't equal 0. Okay, for all real numbers. That's why they always just throw that at the end. But x can't equal 0 for the domain. And our range is going to be the same. Y can't equal 0. It curves away for all real numbers. And if we were looking, this would be our horizontal asymptote. So a horizontal asymptote is x equals 0, and the vertical asymptote is y equals 0. Okay, correction. Horizontal asymptote, this should be y equals 0, and this one should be x equals 0. Okay, we're going to move to page 434, and this is showing what these rational equations look like. Whoops, sorry, I'm not going to put a number in there right now. What they look like when we have transformations involved. Okay, so we'll recognize the h and the k hopefully, meaning this is going to be our horizontal translation. Well, I got an F in translation. Translation. And then this is going to be our vertical, so up and down. Okay, we're going to have a vertical asymptote. So your vertical asymptote is going to show up at x equals h. So whatever your h value is, that's where your dotted line or your asymptote's going to show up. And then your horizontal asymptote is going to be whatever your k value is. Okay, so example 2 in our textbook has the equation y is equal to 6 over x minus 2 minus 3. Okay, so it says sketch the graph of the function using transformations and identify any important characteristics of the graph. Okay, so maybe we want to pick some things out that we can tell right now just so that we can keep them in our head. Okay, so do we know what transformations are happening by looking at this equation? Okay, so we'll have a vertical translation, that means an up and down, at what? Okay, vertical translation of -3, so I'll put down 3. A horizontal translation of what? Okay, +2, so that means to the right 2. Okay, can we tell where there's going to be asymptotes on here? Okay, so we're going to have a vertical asymptote at what? At 2. Okay, vertical asymptote, so we'll say x equals 2. And then a horizontal asymptote, so that'll be a y equals what? -3. Okay, so we've picked those important parts out already. And then remember when we used to graph these way back in chapter 1 where we just graphed polynomials or whatever we did? We always went back to the original picture, right? So the original picture in this situation is going to look like this. Okay, because it's a 6 over x, and then we moved it 2 to the right and down 3. Okay, so this would be the original one. So this is the guy that we're going to graph first, and then we're going to move everybody. Okay, so graphing this original equation, and then we're going to transform it afterwards. So if we make a table of values, let's just try to pick some points so we can figure out what the picture is going to look like. So I'm going to probably pick even things that can divide into 6. Okay, so if I had my x is 1, my y would be 6. Okay, and so I'll draw my beautiful diagram over here. 1, 2, 3, 4, 5, 6. Okay. And then say I had my x as 2. 6 divided by 2 is 3, so my y would be 3. So when I'm 2 over, I'm 3 up. And then what if I had my x as 6? Then my y would be 6 divided by 6 is 1. Okay, so we have what this picture is going to look like, and then I could do the negative versions of these also, right? So if this was -1, this would be -6. This was -2, -3, and if this was -6, it'd be -1. So it should look like 1, 2, 3. Okay, so this is our original picture before transformations. Okay, so our transformation, remember, was 2 to the right and 3 down. Okay, so that means our x points are going to get added 2 to them. So this will be a +2, +2, +2 to all of them. And then our y's are going to move down. So then it's going to be a -3, subtract 3, subtract 3, subtract 3 on all of those. Okay, so you can either change the points on the table here, or you can just mark your point and go 2 to the right and 3 down and mark your new point. Okay, whatever floats your boat. So our table, this will be our new table. So if this was 1 and we had to add 2, this new point's going to be 3, and I'm just going to add all the 2's to the x side. So 2 + 2, 4. Then I get 8. Then I get 1. Here I get 0. And then I get -4. And then my y's are all getting subtracted 3 from them. So 6 - 3 is 3. 3 - 3 is 0. 1 - 3 is -2. -6 - 3 is -9. -3 - 3 is 0. And then -1 - 3 is -4. Okay, so now that we have those points, we should be able just to mark them on here and then draw our picture. Okay, so 3 over and 3 up is here. And if we wanted to check, this was the original point, and 2 over and 3 down is that point. So we would have hit it right. Okay, and then we have 1, 2, 3, 4, and 0. And then we have 1, 2, 3, 4, 5, 6, 7, 8, and -2. Okay. I'm not going to draw the shape right at this moment. I'm just going to finish marking the points. We have 1 and -9. And then we have 1 and -9, 0 and 0. Does that seem a little crazy or no? Oh, this one? This one? Perfect. So it's not supposed to be -9. And this is 0, 0. Okay. -9, -6. Okay, perfect. -9, -6, -4. There we go. So this one's correct. Then this one should be 0 and 1, 2, 3, 4, 5, 6. And then this one should be 1, 2, 3, 4. Like that. Okay, and then this is where it's important that we mark the asymptotes on here also. Because remember, this looked like the equation that we're drawing now looked like this. Correct? Okay, so we had said there was an asymptote at 2. So at 2 there was the vertical asymptote. So we'll draw them there. I missed them by a little bit. And then we had one at -3 also. 1, 2, 3. Okay, so we have our asymptotes, and then we can just draw our picture. And it sometimes helps to have your asymptotes in there because you curve away from them. And here's our other picture, and we're curving away there.